Welcome to Life in Biology. I'm Dr. Joel Graff, and this is a lecture, condensed lecture for my Principles of Living Systems students, POLS, for those who can't have trouble saying Principles of Living Systems. And this is the first lecture. We're actually going to call it Lecture 0. It's an intro to chemistry. So let's just jump right in. The elements that we're going to work with most often when we're talking about biology, they make up the majority of living organisms, are hydrogen, oxygen, nitrogen, and carbon. Next to those names, I wrote the one-letter abbreviation, H, O, N, and C. It makes the word or abbreviation honk if you say them in order. And we're going to remember it as honk because we're going to remember that hydrogen atoms like to make one covalent bond, oxygens like to make two, nitrogens like to make three covalent bonds, and carbon likes to make four bonds. Over here is an example of an organic molecule. It's an amino acid called alanine. But mostly I just want to take a minute to look at this molecule and see that indeed for every hydrogen there is one bond, and as we work our way around we can see that there's one bar connecting each hydrogen to another atom. Oxygen likes to form two bonds, and so here we've got an oxygen that is double bonded to this carbon molecule. This oxygen, instead of a double bond, it's a single bond to the carbon with a single bond to the hydrogen. Nitrogen likes to form three bonds, and here we have nitrogen here, 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 and here. The two dots are just, I should have probably not drawn them in, or else I should have drawn some dots next to these oxygens to represent some electron pairs. Anyway, moving on to carbon. We've got three different carbon atoms in this amino acid alanine, and each of those, if you go ahead and look around it, is connected to four other atoms through single bonds. The one exception is this carbon. It has two single bonds and one double bond, and 1 + 1 + 2 = 4, so it also followed the rules that we had set up for ourselves. If you were given the molecular formula for water, it's H2O, and if you just look at our honk rules, you would know that an oxygen with a single bond to a hydrogen and another single bond to another hydrogen, that's the only way you can arrange those three atoms, those three elements, in a molecule. Next up, of course, if you're going to talk about chemistry, you need to talk about the periodic table. The periodic table is super handy once you know some of the trends and patterns that are in a table. And in this case, we've got nice columns and nice rows. Sometimes the rows, there's a gap in between them, but the columns are referred to as groups. So we've got group 1, group 2, group 3, all the way over to group, I don't know, I'd have to count however many columns wide this is. But anyway, we've got columns as groups, and then the rows are going to be called periods. And when we learn about how electrons float around the atoms, we're going to see that the periods have something to do with how many shells of electrons we have to deal with. Electron shells are a more complicated topic than I'm going to leave you with the impression of, but the thing to know is that for our purposes, we're just going to deal with some of the lighter elements. Speaking of those lighter elements, we've got hydrogen, oxygen, nitrogen, and carbon circled on the periodic table here, and those are the ones we're going to focus on. In fact, most of the elements we're going to deal with are in the first three periods of the periodic table, so let's just cross out that whole bottom 2/3 of the periodic table. I'll leave that for a chemistry teacher to teach you about. Next up, we're going to look in the rows, and we see that in the top row or period, there's hydrogen and helium. So there's a total of 2 elements listed in that top period. We've got 8 elements listed here on the second row or period, and 8 elements in the third period of the periodic table. Those numbers 2, 8, 8, and 8 are going to come back to us here in a second. So let's talk about atoms. Atoms are extremely small. The only thing smaller than atoms are particles, and then the subatomic particles are whatever that make up the particles. Each atom is going to have some characteristics. It's going to be based on the number of protons. Protons are one of the types of particle. So the 3 types of particles we're going to deal with are protons, neutrons, and electrons. So there's how you spell proton, and again, hydrogen was our first atom in the periodic table. It has 1 proton. Helium has 2 protons, 3 protons in lithium, 4 protons in beryllium, and so on until you get up to 118, and I don't know how to pronounce that. So the number of protons is what dictates what element you are working with. We've got protons, neutrons, and electrons. So let's talk about some of their properties. So the first property we're going to consider is charge. Protons have a positive charge. How positive? Well, we're just going to say +1. Neutrons have a neutral charge, so we'll give that a 0. And electrons have a negative charge of -1. So if we have an atom that has lots of protons, neutrons, and electrons, if the number of protons and the number of electrons are equal to each other, we'll have an overall neutral charge or charge of 0 for that atom. We'll talk about what happens if the number of electrons differs from the number of protons later on. Next up, we've got mass. Of course, these are very small particles, and so they're so small we have to come up with a unit called an atomic mass unit to describe it. The protons and neutrons are each about 1 atomic mass unit. In biology, we sometimes use daltons and kilodaltons to describe the size of larger biological molecules. And so, for example, when we get to proteins, we often talk about the size of proteins in kilodaltons, or that is thousands of daltons. So those protons and neutrons are each 1 atomic mass unit, and then electrons, for our purposes, we're going to say it's 0 electron mass units. I believe in Khan Academy they said it was 1/1800, but that's close enough to 0 that we're going to just ignore any mass that an electron might have. Next up, we've got location. These 2 molecules, or 2 particles that had some mass to them, they hang out in the nucleus. The one that is super lightweight, it spins around the nucleus in electron clouds or orbitals. In a chemistry class, you're going to be learning about different sizes and shapes of orbitals, but in our class, we are actually going to kind of draw out our atoms in an unrealistic manner, but it's really helpful for understanding how many covalent bonds each atom might want to make. So let's take a look at this atom here. We've got 18 protons and 18 neutrons. If an atom has 18 protons, it is the element argon. So we're dealing with argon here. Down here I said there's 18 electrons, and we'll notice that out of those 18, 2 of the electrons are in the first shell, and they're paired up. Electrons like to form pairs. The next shell of electrons that are spinning around the nucleus, there are 8 of them, or 4 pairs. And then the next shell, there are 8 electrons, or 4 pairs. Again, the electrons like to be in pairs, but if you notice the numbers 2, 8, and 8, those should sound familiar. They're in 3 different shells as you go out from the nucleus to the outer shell. It's 2, 8, 8. So let's just jump back to the periodic table. You'll see that there are 2 elements in the top row or period of the periodic table. The next row has 8, and then the next row has 8. And so 2, 8, and 8, and what do you know? We end up at argon. So that atom we drew is argon, and if there were to be any more electrons that tried to join in on this molecule, they would have to go into another shell. But the atom is happy, in air quotes, because it has 8 electrons in its outer shell. And because it's happy with the 8 electrons it has, the elements that are in the far right column, far right group of the periodic table, are known as the noble gases, and they are not very reactive with anything else. And so you don't get a lot of bonds, for example, forming between helium and any other atoms. Whereas in the center of the table, we've got some elements that like to form and share electrons with other groups. That sharing of electrons are called covalent bonds. Alright, I think I've said everything I need to say for this lecture. And yep, there are no more slides. That's 13 out of 13 slides. Stay tuned for the next lecture. We're going to finish off our intro to chemistry, and then we're going to focus on organic chemistry. Again, we're not going to spend too much time in this class on chemistry or organic chemistry. We're going to move on to things like genetics and cellular metabolism and stuff like that. But from time to time, we're going to have to talk about things at the level of a molecular scale, and so it's good to know this chemistry.